This is a GCBASIC tutorial for the PIC18FxQ35 chip family. This is a bonus video. Let me just explain. I put another tutorial in before I go over to the next subject. So this is going to show some data on an LCD. I am not a great user of LCDs, hence I don't normally cover this in the tutorial, but the particular board I'm using has an LCD, so I should cover it. So like and subscribe this video and subscribe to the channel. So I'm just taking a quick diversion into showing data on the LCD. So what have I got? I've got this board, and this board has a number 12 LCD display. I had totally forgot, I just overlooked it. Okay, so it's not something that I don't use an LCD personally. Okay, it's not something that I sort of gravitate to because I can't get enough information on it. It's okay for solutions, I guess, but for debugging embedded applications, I just use serial. But lots of people use the LCD. So let's have a look. So the LCD is, let's have a look at the board actually. Big cam, LCD, big LCD. It's actually an OCULAR, which I'll talk about that in a moment. The reference architecture is documented in the schematic, and it's this little box down here on the right hand side. Oh, well, no, it's not. It's the top one here, LCD1. Look, okay. There are two different types of LCDs. This is an OCULAR. I have some spares if you need some. Okay, so what does it look like in terms of its connection? I've just zoomed in on that. Okay, it has a number of key connections. It has some control lines, and these control lines consist of these three here: enable, read, write, and R and S. It has a supply VEE at 5 volts. It has 4 bits for the data. This LCD also requires power on RD7. And so we are going to see a series of setups to make this work. And what we're going to do is just display some values on it. Really simple. Now, remember, I spoke about this on the last one, especially on this. I mean, I could pull out the VDIO2 on this. I don't think the LCD will work. No VDDI2 power, no domain ID. So I am going to explain. I am going to be using these pins, the green ones. Therefore, I must put voltage on the VDDIO2, which is the green domain. It says VDDIO2, pins on that domain are green, and therefore, if you use those pins, you must put power on the VDDIO. VDDIO2, no power domain. This doesn't work. So let's have a look at LCD output. It's a very old capability, LCD outputs. There are many different ways of doing this, different modes, and we're going to set up this specific one, which is a 4-bit OCULAR, an OM1614. And honestly, you can just add your own. It's not hard to add, but generally this is the approach, and it just works. So we're going to use a 4-bit parallel mode. We're going to have a special initialization tucked away inside the OCULAR to this power control. And we're going to put some power on port D7. Control pins will be on port D, 4 of them. And really, that's it. And we do that through a set of really simple defines. And the moment you put these defines in, you put some defines in. Oh, I've got them on pen. You put some defines in, and all of a sudden, print, screen, print, clear screen, locate, they just work automatically. They just work, okay? So what we're going to do is same as serial. We're going to set up the LCD we're going to set up the LCD here through the constants, and then we are going to read the ADC, set the LEDs, but we're going to send some values to the LCD. That's it. It's really simple. So what we're going to do is really focus on the setup of the LCD and how you send values. So let's have a play. Am I in GC? Am I in GC Studio? I don't know if I am. Probably not. Probably close it down. GC Studio, GCS. Open up GC Studio. And we've been here before many times. I'm going to open up my project, which is actually open recent. It's an LR18F. I can just open it and it will open up the IDE. There we go. Empty, not very friendly. Top left, click on the Explorer and load in a 105 reversible LEDs with variable delay to LCD. Click, click, click. And it's already here. Look, it's already highlighted the code for me. Look, sort of cheating, really. Okay, I'll come back to that. So I don't know why that's hanging. I think that's there from the previous. I don't know. I'll leave it there. Chip, option explicit, config, all explained previously. If you want to change the config, go and play in PIC-info. These are the sets of constants that I've defined our LED so far, our potentiometer, and the switch that we've been using. There is a note at the top of here around VDDIO2, critical for operation. So let's have a look at what we've got here. Set up the LCD. Set of really simple. A constant called LCDIO4. That means I'm going to be using a 4-pin mode. There are many different modes. Go and have a look in the help. Press function key F1 will take you into straight into the LCD, and you've got modes. I'm using mode 4 where I need to define the RS, the RW enable, and 4 data lines. Let's do that then. I'm just going to ignore this for the time being, if you don't mind. Oh no, let's be quite fair. We know it's an OCULAR, therefore we have to define it. It just modifies the initialization process. We have to put some LCD power on. This particular OCULAR needs power. No, I haven't come across another one that requires this, but it's the board. It allows you to do it and change that. It changes the port, and then we've got the hardware settings for the RS, RW enable lines. I set them to different ports, and then the data lines, the 4 data lines, LCD DB4 to 7, 1, port D0 to D3. That is the whole setup. The initialization process will happen automatically based upon that. Now, if you set the LCD IO4, then it will start looking for certain constants, and if they're missing, you'll just get an error. You'll get a compiler, go back and check. All right, so how do I output things? Well, I say print, clear screen. I can print constants, values. I can clear it. I can use locate. I can get data from the LCD if it's the right type. It just works. The rest of the code we've seen previously. It's going to display the value of the ADC, the direction of the LCD travel, and what's happening. So why don't we just go to desk cam? I'll move the camera over to there, out the way, look, and I'm going to program it. I'm going to program this by pressing function key F5, and it's executing the task to compile the program. It has erased the part, and it's done it. And on the LCD, if you looked carefully, there's a string. It told you the chip type, the frequency, and now it's doing the update. It says it's moving to the left. Push it. The LEDs are moving to the right. There is the 4 LEDs. And the potentiometer. Minimum of 50, maximum of 1000. I'm not going to put them 1000 because it just screws up the display. But look, that's updating that quite quickly, and it does update it quite quickly. There we go, 1000. is one second, and the LEDs are moving every 1 second. So to set up an LED, LCD, is extremely simple. As I've shown you, you specify the type of interface you want, and you can have serial interfaces, one-wire interfaces, 8-bit, I2C, lots of different interfaces. Go and look at the help. These are modifiers for particular the OCULAR, and this is the only board where I've ever seen an OCULAR, to be quite frank. And then you need a series of constants to define the LCD hardware, and that exposes for you print, clear screen, locate, etc. on all the commands that are allocated with that. And if we look at the help, and we look at the contents, command reference, there's graphical LCD, which we'll look at later on, LCD crystal display. There is, I'll zoom in on that so you can see it. Might help if I zoom in. Let me move that across. Oh, there we go. That's overlaying there a little bit too much. There we go, look. LCD, there's an overview. You get clear screen, get backlight control, hexadecimal values, displays on and off, and there's lots of demonstrations on how to do this, to be quite frank. Many demonstrations, far more than I can show you, but I wanted to give you a bonus. So these are the commands that are exposed. Back to the code. We look at the assembly, what's happened, and open up the assembly by function key F4, open ASM. We look at the initialization, loads of variables. It says in here, init_sys, which is the initialization of the microcontrollers in terms of the ports and frequency, and it said there is a special init for the OCULAR. It is a slightly different architecture, that particular LCD. Normally, you would just call the init LCD. So, automatically added the moment we added it. If we miss something out like that, try to compile it, we'll get an error, and the error message was LCD parameters not set up correctly, and it gives you some hints on what to do. Is there a helper in here? There's no. Someone should write a helper. Just retest that. There we go. It's fantastic, really. It is quite simple. Very easy to set up an LCD. I thought I'd do a bonus on that. There we go. Back to PowerPoint. So I promise now I will go and do timer overflow. 8-bit and 16-bit. I'll go and do that now. Enjoy.